All right. Hello, everyone. Welcome to Synergetic Stream number 13.0. It's November 20th, 2021. Today in Synergetic Stream 13.0, the spirit is grounding, anticipation, 312. And 312, as maybe will come out over the next little bit, modelability, the first section is going to be the most general and the most kind of the third layer. And then we're going to drop down into 723, redundance. That's a pretty specific example. It's looking at kind of minimal systems in synergetics. And then 784, 2, this is about Allspace-Filling Tensegrity arrays, which are about how the minimal units relate to each other. So it's kind of going from the third layer down to the first layer and then up to the second layer that's bridging the minute particulars, the specifics, with the macro. We're going to go over the key memes and themes and the things to integrate as usual, and then go right into the sections of synergetics. So synergetics is relational and multi-scale thinking. It's connected to accessible experiences. It doesn't have infinitesimals or points in line or lines or planes, at least in the usual sense. And synergetics frames design as anticipatory cybernetic science. There's this relationship between tensegrity and synergetics, kind of applied synergetics being tensegrity, something that's going to come up later today. It's almost like engineering and physics. A big idea is that space has a shape, and it's not just any shape. There's some ways that balls just pack. And there's various ways to think about structure and pattern, also things we'll talk about today. Universe is the total scenario, and systems are always specified, and that means a subsystem being partitioned out from the larger system, and that system has a shape and a connectedness. And then there's this 4D meme. Here's the 4D time lock symbol, and 4D is meaning various different things, referring to the tetrahedron, and we're going to talk about that too. So here in the things to integrate, we can list some next steps and notes. Also, if you're watching on YouTube live, then I can look in the live chat now. So anytime during the stream. These are some questions like, what do we prefer and expect when we're learning and applying synergetics? And what are the connections with synergetics and some of these other areas that we talk about? How can we participate in modern and future synergetics? And some future sections to look at or other links. If people send me things to talk about, that's helpful, or new resources or ones that have been overlooked. Let's go to section 900 in Synergetics. All right. Here's the version drawn from R.W. Gray's website. 900, modelability. Definition, modelability. Modelability is topologically conceptual in generalized principle independent of size and time. Ergo, conceptual modelability is metaphysical. Conceptual formulation is inherently empirical, and as such is always special case sizing and always discloses all the physical characteristics of existence in time. So, modeling is kicking off a whole new centennial in synergetics with the 900, and models are metaphysical. Here on this table, we can kind of start to build up these dualities or binaries and think about kind of models versus the form distinction that's going to arise. So synergetics, definition of synergetics, the book. Synergetics is a book about models, humanly conceptual models, lucidly conceptual models, primitively simple models, rationally intertransforming models, and the primitively simple numbers uniquely and holistically identifying those models and their intertransformative, generalized, and special case number value accountings. Interesting definitions: geometric models in synergetics and conceptual. So all these different kinds of models and their inner transformations, how the models relate to each other, just like some of the statistical distributions are special cases of each other, or like some models can be seen as special cases of other models. This is a geometric and integer accounted for scalable or multi-scale model framework that uses vectors and geometry and tries to work with the way that nature is rather than imposing another coordinate system as primary. Model versus form. Model is generalization. Form is special case. The brain, in its coordination of the sensing of each special case experience, apprehends forms. Forms are special case. Models are generalizations of interrelationships. Models are inherently systemic. Forms are special case systems. Mind can conceptualize models. Brains can apprehend forms. Forms have size. Models are sizeless, representing conceptuality independent of size. So on the left side is kind of the abstract column, the modelability. That's what Synergetics is about. It's kind of like the map as opposed to the territory. Also interesting that forms are like the physical side, but Platonic forms are the abstract ones. So it's kind of like map and territory, or theory and inference, thought, and then application or action. It's the metaphysical versus the physical. The mind. So the mind is conceptualizing models. Brain can apprehend forms. So brain physical. Whoops, this is switched. So angle is general, like 60-degree angle could be any size, but frequency is its specific size. Models can also be atemporal or eternal, like generalizations that abstract across time, whereas special case always entails time and size and place duration. And maybe a little bit more speculatively, Synergetics is a book about models. That's 900.21. What is Synergetics? Well, it's a book about models. And then tensegrity is always going to be in realized cases, like that tensegrity sculpture over there, or this model of a bridge. And this is kind of like generalization versus minute particulars. So I thought before we jump into this section on powers and dimensions, there can be a Blakean interlude. Okay, so here's the table from the previous slide, as well as, also why are there dialectics like these? Could it be otherwise? Like, could there be a trifold or a quaternary distinction? What would that mean? Or why is it better or worse for something? And yeah, what does this all mean? So here's that table. Okay. And here's one of the reasons why I think the phrase minute particulars kind of has a nice tradition. So here is a section from Blake's work, Jerusalem. I won't read the whole thing. So I'll start in the fourth line. Labor well the minute particulars, attend to the little ones, and those who are misery cannot remain so long. If we do but our duty, labor well the teeming earth. He who would do good to another must do it in minute particulars. General good is the plea of the scoundrel, hypocrite, and flatterer. For art and science cannot exist but in minutely organized particulars, and not in generalizing demonstrations of the rational power. The infinite alone resides in definite indeterminate identity. So, also invokes, of course, free energy principle for a particular physics and the whole idea of particular states in active inference. So, it's the minute particulars of the specific that also have to be contextualized in this sometimes wildly mythopoetic way. And so here are three of Blake's most famous pieces of art. Here's Newton, the geometer, tracing out geometry. Here's from Europe, a prophecy. with a geometer creator. And then here's one, not sure exactly what this one comes from again, but another sort of geometric meaning also kind of invokes a valediction forbidding mourning by done. And then also, here was an interesting, when researching this, found this work by Julie Justin from 2008, and thought it was very much like the kind of Bucky and Blake crossover point, because this is going to set us up for looking into the specifics, the particulars of some shapes. Blake's Jerusalem, the emanation of the giant Albion, presses the idea of minute particulars, discrete, significant units of sound and meaning. Lohse works with such materials to build a system of signification and reading that answers the Blakean imperative. Labor well the minute particulars, attend to the little ones. This paper considers how minute particulars expose the dumb, embedded structures that produce Albion's melancholy, and it explores how Jerusalem resists dumb despair by creating a counter-melancholic poetics that figures minute particulars as both the symptom of and the cure for Albion's melancholy. As the smallest units of sound and meaning, minute particulars are essential to Blake's production of a liberated poetics, for he who wishes to see a vision, a perfect whole, must see it in its minute particulars. So the idea that the subunits are, quote, dumb, like let's think Tommy, deaf, dumb, and blind, that kind of insentient, mere active inference, non-aware parts of ourself. That's kind of like reductionism in a sense. It's just saying they're, even for meaning, like melancholy of the undivided kind of cosmic person, Albion, even that arises from these embedded, nested, hierarchical structures interacting, the cogs. And then Blake, and then we can ask, how does Bucky do this as well, proposes that a counter-melancholic poetic that figures minute particulars as both the symptom of and cure for Albion's melancholy. So pretty cool how Blake kind of took poetry to that ancient bardic place of the sound and the minimal units of meaning. And then also we're going to be thinking about minimal geometric units of meaning with this emergence, and we don't deny the complexity of the larger systems by sometimes also taking a lot of time to describe the minimal system. Those are kind of hand in hand, and maybe there's something more to explore here too. So first, in modelability, powering in the Synergetics coordinate system. In the operational conventions of the XYZ CGS, that's probably the centimeter gram second system of units, coordinate system of mathematics, physics, and chemistry, exponential powering meant the development of dimensions that require the introduction of successively new perpendiculars to planes not yet acquired by the system. So as we think about 1, 2, 3-dimensional data sets or geometries, we can have the perpendicular lines and the planes intersect. It looks like the XYZ plane. And then you have the 1 centimeter side of the cube. And then that 1 centimeter cube is 1 gram of water at 4 degrees Celsius. And so it's this whole coordinate system and a relationship between length and weight and different units or quantities in the world that are very tied up. So it's just like those cubes of metal or plastic in the elementary school with the yellow cubes and the centimeter. That is what partially bakes the cubic form into our math. In Synergetics, powering means only the frequency modulation of the system, i.e. subdivision of the system. In Synergetics, we have only 2 directions, radial and circumferential. So in Synergetics, because it's this sort of packed spheres geometry, given the intersection point of the 0 coordinate axis, all you need is from there the radial vector and then the circumferential vector, and that will be able to describe at high frequency shapes, quote, high dimensional systems, which is going to be explored more in this section. In the XYZ system, 3 planes interact at 90 degrees, 3 dimensions. In Synergetics, 4 planes interact at 60 degrees, 4 dimensions. In Synergetics, there are 4 axial systems, A, B, C, D. There is a maximum set of 4 planes non-parallel to one another, but omnisymmetrically mutually intercepting. These are the 4 sets of the unique planes, always comprising the isotropic vector matrix. The 4 planes of the tetrahedron can never be parallel to one another. The Synergetics ABCD 4-dimensional and the conventional XYZ 3-dimensional systems are symmetrically intercoordinate. XYZ systems cannot rationally accommodate and directly articulate angular acceleration, and they can only awkwardly, rectilinearly articulate linear acceleration events. So from the tet as a shape, you have another axis of spatial information. And here's from grunch.net, from Kirby's site. So this is the quadray coordinate system. So from that one point, it's a 4 tuple. You get 4 points of information. You can represent the points in 4D, just like you could represent that point in XYZ, but the planes are non-overlapping in their symmetry. Whereas like you could imagine some other shapes that don't have even close to some of the nice properties of the tet, like it being the minimal shape, but just you have other larger shapes where there are parallel sides. The Synergetics ABCD 4-dimensional, 4D, and the conventional XYZ 3-dimensional systems are symmetrically intercoordinate. So here we can look at 2 images from this quad rays intro. Here, which is going to come back with the Synergetic scaling coefficient, here on the right is the tetrahedron from the bottom right with those quad rays coordinates. And 2 tetrahedra that are overlapping, like as tet above, so tet below. That is all of the 8 points of a cube. So that's one of the key crossover points in Synergetics. Now, let's go back to that XYZ CGS coordinate system. In that world, the side of that yellow cube, that means 1 centimeter cubed, 1 gram of water at 4 degrees, 1 calorie, etc., kilojoule, whatever it is, all of that is predicated on that green edge being called 1, just scaled to 1. This is not a re-questioning of Peano's axioms. This is just saying, let's call this diagonal 2. Because everyone has done a little geometry and found out, okay, I guess you can really easily calculate the number of blocks needed for a block structure. Just height, length, width. But then any other shape, first off, is going to be fuzzy because you have to kind of Minecraft it, and it's going to have like pixelation because it's cube. So you're never, and then if you go really fine, you can kind of approximate how many cubes you're going to get. But every other shape, every other non-cubic shape, it always has some weird ratio. So we get that nice integer cube with a 1, but then pretty much every other cool shape doesn't have an integer volume. Synergetics flips that, or is at least in complement to it, and says, let's call this side, which you would call root 2, usually. Let's have that be worth 2. And the reason why is it's kissing spheres of radius 1. 2 spheres of radius 1 are going to end up making that 2. Unity is plural at minimum 2. And then here is that tetrahedral coordination system with the point of symmetry in the origin where the blue 4 dimensions intersect and the 3 green directions intersect. That's where they meet. But the blue defines a closed coordination system, closed like space-time, and the green defines a open coordination system, which is going to come back later. And then you get the green symmetry axes and points within a tet world. But from XYZ CGS, you never get the tet. Synergetic geometry discloses the rational fourth and fifth powering modelability of nature's coordinate transformings as reference to the 60-degree equitriangular isotropic vector equilibrium. So here's the vector equilibrium, all of the edges of the 12, all the 12 vectors being balanced, and the shape it inscribes being on the outside. XYZ volumetric coordination requires 3 times more volume to accommodate its dimensional results than does the 60-degree coordination calculating. Therefore, XYZ 90-degree coordination cannot accommodate the fourth and fifth powers in its experimental demonstrability, i.e. modelability. This cube that has the as tet above, so tet below, has a volume of scale 3 tets. In the coordinate vectorial topology of synergetics, exponential powers in physical model dimensioning are identified with the number of vectors that may intercept a system at a constant angle while avoiding parallelism or congruence with any other of the uniquely convergent vectors of the system. Angular and linear acceleration. Synergetics accommodates the direct expression of both angular and linear accelerations of physical universe. The frequency of the synergetics coordinate system, synchrosystem, simultaneously and directly expresses both the angular and linear accelerations of nature. The three-dimensional XYZ CGS system of coordination presently employed by World Around Science can only express directly the linear accelerations and evolve therefrom its angular accelerations in awkward mathematics involving irrational, not exactly resolvable constants, CGS per second. F squared, mx times f squared, is cubistically awkwardized into calculatively tattering irrationality. So it's kind of this coarse graining at the finest scale. Our pixels are the wrong shape. The voxels are the wrong shape, and they don't include a bunch of other features that a tet voxel gives. As to these ways in which linear XYZ approaches, let's just say XYZ CGS approaches, how do they fail or accommodate angular acceleration? Well, check out ActInfLab Livestream, number 26.0 and number 33. But it's one thing that might be relevant here is what's known as the Helmholtz decomposition. So here's the total current of a vector field. And the total current of the vector field is being described in these 3 different directions. And the Helmholtz decomposition partitions this field into an irrotational kind of like gradient aspect, the irrotational or longitudinal current, and then the solenoidal or tangential flow. And so it's related to vector field partitioning, which synergetics is vectorial geometry. So we're totally within vector science. And this is one non-synergetics way, but potentially generalizable too, to partition or decompose a field into different components. And then the way that that matters for decision making, here's an active particle, and it is following motion that is governed by a mixture vector of some irrotational component, like going up the mountain, and then some rotational component, like on the iso contours. And if this is a decision-making landscape, then this can be a very good model for local optimization and the role of changing environmental inputs. And then, interestingly, this is from number 33, stochastic chaos and Markov blankets. So this is, again, a model like Synergetics. Synergetics is a book of models. Note that there is no claim either the original Lorentz system or coupled Lorentz system possesses a Markov blanket. The claim here is there exists a Laplace approximation to these kinds of systems that in virtue of the zero elements of the Hessian feature Markov blankets. And here's that fourfold system. The fourfold partitioning of nodes on a Bayesian graph involving perception, cognition, and action, and niche, those four components being the minimal system. And then digging one layer more, unity is plural and at minimum 2, with the minimum coupled systems having at least 2 nodes within this partitioning of 4. So, pretty interesting, and we'll return to the regular Synergetics content, but maybe there's a lot of overlap that could be explored there. 20. Convergence. In the topology of Synergetics, powering is identifiable only with the uniangular vectorial convergences. The number of superficial, radiantly regenerated vertex convergences of the system are identified with a second powering and not with anything we call areas, that is, not with surfaces or any experimentally demonstrable continuums. Calculation of local events. All local events of universe may be calculatively anticipated in Synergetics by inaugurating calculation with a local vector equilibrium frame and identifying the disturbance initiating point, direction, energy of relative asymmetric pulsing of the introduced resonance and inter-transformative event. So let's imagine at the special point where the flow on the landscape is 0 in 12 dimensions, 6 dimensions, 4 dimensions, n dimensions, and then that's something like a vector equilibrium. And then maybe there's something within the approximation of the landscape such that a physical or a topological or a geometric perturbation could be modeled. Time and dimension. Synergetic geometry embraces all the qualities of experience, all aspects of being. Measurement of width, breadth, and height are awkward, inadequate descriptions that are only parts of the picture. Without weight, you do not exist physically, nor do you exist without a specific temperature. You can convert the velocity times mass into heat. Vectors are not abstractions, they are resolutions. Time and heat and length and weight are inherent in every dimension. Ergo, time is no more the fourth dimension than it is the first, second, or third dimension. That's sort of the, that's not your third eye, that's your first eye argument. So time is often seen as the fourth dimension because the first three are the timeless XYZ, CGS, physics, abstraction. And it doesn't matter if time's the first or the fourth in some formulations, so it's a little bit more like rhetoric than it is a real claim, because someone could say, okay, it's the, now we call XYZ the second, third, and fourth. That would still be a paradigm shift locally in some way. But even then, time is modeled in this like kind of 3+1 way as another dimension. And yet the specifics of systems, going back to here, like the special case has a time and a size and a place. So Bucky's claim is that weight and temperature are needing to be described in a vectorial world. And we get another degree of description with a tet. No time, no dimension. Time is dimension. Because basically you have events that are radiating in and radiating out. Either they're locally pulsating or they're kind of omni-radiating or omni-gravitational. Those are happening for whatever reason, apparently or not, to be happening at the speed of light. That's where the speed of light comes into EMC squared, which we'll come to. But time is a fundamental part of our spatial, locally interacting system scenario. Maybe universe, maybe not. Time is in synergetic dimensioning because our geometry is vectorial. Every vector equals mass times velocity, and time is a function of the velocity. The velocity can be inward, outward, or around, and the rounding will always be chordal and exactly equated with the inwardness and outwardness time expendabilities. The Euclidean-derived XYZ coordinate geometry cannot express time economically around, but only time in and out. Synergetics inherently has time equanimity. It deals with anything that exists always in 1x1 time coordination. So this is kind of this vector-driven understanding, things being in motion and existing through time. Time is kind of built in there with vector fields, but it's abstracted away from. And then the velocity can be like in or out, radiation or gravity, or it can be around. So it turns out that we need that fourth dimension for the aroundness, kind of for the solenoidal flow, maybe, and other things. And then I wonder, would be awesome to hear what people think or talk, like, what is 1x1 time coordination? Is it a timeless? Is it kind of the world of Kairos? Is it the world of simulation, discrete time, etc.? So cool to hear what anyone thought about that or just anything else. 962.50, omnidirectional regeneration. The coordinate systems of synergetics are omnidirectional regenerative by both lines and planes parallel to the original converging set. The omnidirectional regeneration of synergetic coordination may always be expressed in always balanced equivalence terms either of radial or circumferential frequency increments. That's going to help with calculations. So first power, one dimension. In conventional XYZ coordination, one dimensionality is identified geometrically with linear pointal frequency. The linear measure is the first power or the edge of a square face of the cube. So in XYZ CGS world, a one-dimensional thing is a point, linear pointal frequency. And then the measure is of 1 is the side of the cube. In synergetics, the first power linear measure is the radius of the sphere. That's why the diagonal is 2 on the cubic crystal packing of spheres. Synergetics constant. The synergetics constant was evolved to convert third power volumetric evaluation from a cubical to a tetrahedral base, and to employ the ABCD four-dimensional systems vector as the linear computational input. In the case of the cube, this is the diagonal of the cube's square face. Other power values are shown in table 963.10. We have to find the total vector powers involved in the calculation. In synergetics, we are always dealing in energy content. When vector edges double together in quadrivalence or octavalence, the energy content doubles and fourfolds respectively. When the vector edges are half doubled together, as in the Icosahedron phase of the jitterbug transformation, halfway between the vector equilibrium 20 and the octahedra compression to fourfold and fivefold contraction with the vectors only doubled, we can understand that the volume of energy in the icosahedra, which is probably the same 20 as that as the vector equilibria, is just compressed. Ties together a lot, but saying that the volumetric ratios of the integer constructions of these shapes having a volume 20 for the vector equilibrium, and then that 20 being able to compress to 4 or 5 fold, because 20 is 4 times 5. And the idea of a synergetics constant, which we'll probably explore another time, where it's not too viewable here, but this is like where computational synergetics could be awesome. These could just be calculated. We could have a whole ontology for all these ratios. And it's kind of like this synergetics constant is going to bump the dimensionality up. So it's kind of like sometimes you need to use C, sometimes you need to use C squared, sometimes you might need to use C cubed or to the 3/2 power. Those types of things are going to be integerized and given a mechanism of emergence and supervenience for and put into an integer accounting framework whose shape is more like kissing spheres than it is the open-ended flat Earth world. In Einstein's E equals mc squared, m is volume to spherical wave ratio of the system considered. Mass is the integration of relative weight and volume. What Einstein saw was that the weight in the weight to volume ratio, i.e. the mass, could be reduced and still be interpreted as the latent energy per volume ratio. Einstein's m is partially identified with volume and partly with relative energy compactment within that spherical wave's volume. There are then relative energy of reality concentration modifiers of the volumes arrived at by third powering. So this is a little bit esoteric, so if anyone has thoughts, that would be nice to hear. But it's almost like this is trying to get at the third dimension. We're taking some quantity that Bucky is concerned about how the surrogate variable, the latent variable analysis, partitions onto these two parameters, and suggesting that maybe we would just want like a, E prime equals S. Like the synergetics constant is some third powering that describes that radiative and gravitational component of the universe or scenario. So if mc cubed or mc squared were distilled into a cubic something, then maybe that could just be the new scaling number as just that number being itself. And then just teach the larva that, and then they'll think that's the case. All of the frozen volumetric and superficial area mensuration measurement of the past has been derived exclusively from the external linear dimensions. Synergetics starts systems mensuration at the system center and employing omni 60-degree angular coordinates expresses the omni equal radial and chordal modular linear subdivisions in frequency of module subdivisioning of those radii and chords, which method of mensuration exactly accommodates both gravitational coherence and radiational expansion calculations. As the length of the vectors represents the given mass times velocity, the energy involvements are inherent in the isotropic vector matrix. Synergetics is a priori nuclear. It begins at the center of the always centrally observing observer. The centrally observing observer asks progressively, what goes on around here? Okay, so just like the S that was proposed, just some kind of magical scaling synergetics factor, not magic, but hopefully you know what I mean. That transformative S is the first power. So that's where TET comes into play. Minimum system, tetrahedral base, scale at the base. Now second power, 2 dimensions. In conventional XYZ coordination, 2-dimensionality is identified with areal pointal frequency, aka area. So, how much area does that wall have? Oh, just x times y. In synergetics, second powering equals point aggregate quanta equals area. In synergetics, second powering represents the rate of system surface growth. So, that's a very fascinating overlap because they're both actually about area, but the xy is just one side of the wall. It's just x times y on half of it. Whereas the shell is the area of, it's the rate of system surface growth. It's the number of nucleation sites on a crystal. It's the surface area or the membrane or the boundary of the system. It's the wave of that radiation that has or hasn't reached somewhere and how much it's growing at the next moment. Spherical growth rate. In a radiational or gravitational wave system, second powering is identified with the point population of the concentrically embracing arrays of any given radius, stated in frequency of modular subdivisions of either the radial or chordal circumference of the system. Vertexial topology. Second powering does not refer to squaring or to surface amplification, but to the number of the system's external vertexes in which equating the second power and the radial or circumferential modular subdivisions of the system multiplied by the prime number 1 if tetrahedral system, by the prime number 2 if an octahedral system, by the prime number 3 if a triangulated cubical system, and by the prime number 5 if an icosahedral system. Each multiplied by 2 and added to 2 will accurately predict the number of superficial points of the system. So it's kind of like knowing the next number in the shell. And there's great equations, simple mnemonics, and amazing computer expressions of these, and empirical demonstration. 964.30, shell accounting. Second power has been identified uniquely with surface area, and it is still the surface or shell. But what physics shows is very interesting. There are no continuous shells, there are only energy event foci and quanta. They can be considered as points or little spheres. The second power numbers represent the number of energy packages or points in the outer shell of the system. The second power number is derived by multiplying the frequency of wave divisions of the radius of the system, i.e. f squared equals frequency to the second power. So we get second powering, the second dimension of abstract spaces, not by painting one side of a wall or by multiplying out in this wall that gets bigger and bigger, and we're just painting it more and more in that XYZ CGS system, but we're having a shell that's growing outwards, and we're just calculating, again, how much paint would have to go over it, but because it's discrete and nucleating sites for a crystal, then it's always going to be an integer number. So you know exactly how many vertexes are on the next shell, and you get that second power relationship. So it's, instead of asking, like, you could still paint that room that looks like a square, you would just be asking, like, oh, how big is the sphere that would have to be for me to paint it as well? And then that's always going to be an integer approximation. 964.31. In quantum and wave phenomena, we deal with individual packages. We do not have continuous surfaces. In synergetics, we find the familiar practice of second powering displaying a congruence with the points or separate little energy packages of the shell arrays. Electromagnetic frequencies of systems are sometimes complex, but they always exist in complementation of gravitational forces and together with them provide prime rational integer characteristics in all physical systems. Little energy actions, little separate stars. This is what we mean by quantum. Synergetics provides geometrical conceptuality in respect to energy quanta. So that's the second power in synergetics. Third power, 3 dimensions. In a radiational or gravitational wave system, third powering is synergetically identified with the total point population involvement of all the successively propagated, successively outward bound in omni-radial direction wave layers of the system. Since the volume point was a tetrahedron and already a priori volumetric, the third powering is in fact 6 powering. N cubed times n cubed equals n to the 6th. Third powering equals total volumetric involvement as, for instance, total molecular population of a body of water through which successive waves pass outwardly from a splash-propagated initial circle. As the circle grows larger, the number of molecules being locally displaced grows exponentially. Third powering identifies with the symmetric swarm of points around and in addition to the neutral axial line of points. To find the total number of points collectively in all of a system's layers, it is necessary to multiply an initial quantity of one of the first 4 prime numbers times 2 by the third power of the wave frequency. Perpendicularity, 90 degrees, uniquely characterizes the limit of 3-dimensionality. Equiangularity, 60 degrees, uniquely characterizes the limits of 4-dimensional systems. So here it's like volume. It's the total point population involvement of all those surface shells being added. So now there's a nice relationship with something like area and something like volume on these expanding shells, which are closely packed. It's like we get second and third power relationships, but our mnemonic for connecting them and understanding them conceptually is going to be a nucleating shape rather than a cube that just expands. Next time, into the fourth dimension, but fourth power. Today, just 3 powers. All right, so that was the big zoom out modelability. Let's go to the micro, the minute particulars. So redundance. The discussion of redundance is going to lead to some discussion around minimal systems, because a minimal system is like the one where you can't have any redundancy. So maybe, I don't know if redundance was just a Bucky-ism, or maybe it was how people used to use the word redundancy. 723. 1. There are metaphysical redundancies, repeating the same thing, saying it in a little different way each time. Well, you can't step in the same river twice, can't be the same biological creature or bundle of experience twice, so sometimes the same words get reread, but the context is always different, and you can't unring a bell, so complex systems, metaphysical redundancies, c'est la vie. 2. There are physical redundancies. When, for example, we have a mass stepped in a hole in the ground and 3 tensional stays at 120 degrees. When a 4th tension member is led to an anchor at an equiradius distance from the mast base and at 1 degree of circular arc away from one of the original 3 anchors, we then have 2 tension stays running side by side. When the 2 stays are thus approximately parallel, we find it impossible to equalize the tensions exactly. One or the other will get the load, not both. That's a pretty interesting example. Something that's already stabilized only has doesn't have any degrees of freedom left to give. So there can only be a limited partitioning of constraints, and some of those constraints will be redundant with others in one moment. Now maybe then the wind blows it one way and the load shifts because now that one's closer. So it's not that it can't, it's just in the abstraction of that case. Grounded in actual engineering experience, that's a generalization that Bucky is making. 3. It is structural redundancy when a square knot is tied and an amateur says, I'm going to make that stronger by tying more square knots on top of it. The secondary knots are completely ineffective because the first square knot will not yield. There is a tendency of the second square knot to work open and thus deteriorate the first knot. Structural redundancies tend to deteriorate the effectiveness of the primary members. So there's all kinds of things like this, but having a bunch of unused pieces of a system is a cost, maybe even an active cost. So that kind of structural redundancy can be identified because of the system's description. 4. There are 2 classes of redundant acts. 1. Conscious and knowledgeably competent, and 2. Subconscious and ignorantly fearful cautionaries. So sometimes we are in the unknown known, the known unknown, unknown unknown, known known, wherever we are. We're making sometimes redundant acts for maybe all kinds of reasons. 5. Building codes of cities, formulated by politicians fearful of the calumny of what may befall them if a building falls down, ignorantly insist on doubling the thickness of walls. Building codes require a safety factor of usually 5 or more to 1. Aircraft designing employs a safety factor of 2 to 1 or even no safety factor at all, while cautioning the pilot through instrumental indication of when he is approaching limit condition. The deliberately imposed safety factors of society's building conglomerates introduce redundancy, breeding redundancy, wherein, as with nuclear fusion, chain reacting the additional weights to carry the additional weights multiply in such a manner as to increase the inefficiency imposed by the redundancy at an exponential rate implicit in Newton's mass attraction gravitational law. Every time we double the safety factor, we fourfold the inefficiency and eightfold the unnecessary weight. So that's a pretty interesting scaling law approach, kind of bringing up that scaling relationship and rethinking it. But now we're thinking of the kind of like safety, like the therapeutic ratio, and airplanes, which have a very high success rate and I think that's fair to say. They design with this explicit understanding of weight, like ships do as well. But one of Bucky's long-term gears to grind is that because they don't have to calculate the weight or the volume to weight enclosing space, architects for earthly buildings make shapes that, whether culturally constrained or not, or they do not consider some fundamentals. So like the skyscrapers being maybe valuable in certain ways, but also their surface area to volume just having a huge heating and cooling costs because it's like a heat needle. 724, three and only basic structures. The original 6 vector-edged members of the tensegrity tetrahedron may be transformed through the tensegrity octahedron phase and finally into the tensegrity icosahedron phase. The same 6 members transform their relation to each other through the full range of the 3 only fundamental structures of nature: the tetrahedron, the octahedron, and the icosahedron. So that's referenced in many other sections as well. The same 6 members transform from containing 1 volume to containing 18.51 volumes. These are the principles actively operative in an atomic nucleus behavior in visual intertransformations. So the 6 are the edges of the tet that are like compression members. So that's the most folded down and compressive that you can be, is the tet. And then there's this intertransformability with some other tensegrity shapes that are going to uncompress the energy through intertransformabilities to enclose a larger volume. Tensegrity octahedron. The simplest form of tensegrity is the octahedron with 3 compression members crossing each other. The 3 compression struts do not touch each other as they pass the center. They are held together only at their terminals by the comprehensive triangular tension net. The same 3-islanded struts of the tensegrity octahedron may be mildly reorganized or asymmetrically transformed. The struts may be the same length or of different lengths. Some tensional edges may be lengthened, while other tensional edges of the surface triangles are shortened. The compression members still do not touch each other. One figure is a positive and the other a negative tensegrity octahedron. They can be joined together to make a new form, the tensegrity icosahedron. And then just to read the icosahedron, the 6-island strut icosahedron and its all-space closest packing capability provide equioptium economy tensegrity universe structuring. So we have 6 edges, and tensegrity is tension plus compression. And that fundamental structural principle is going to result in sculptures that look like this, with the rods, the straight lines being like pieces of metal or like carbon fiber or something, some compressive element, and then the wires being tensile elements. And so the simplest form is to have these 3 edges that are going to be balanced in this way in B. So A is the 6-strut tensegrity tetrahedron. So that's kind of how you get the tetrahedron with the edges being compressive elements, and then the joints, notice how they're not just like coming together like as if it was a wireframe. It's like a little bit more complex, but that's how you get the 6 edges that are in a tensegrity alignment, not just a fixed alignment, even though that's sometimes a useful heuristic too. So then B, the 3 compression struts, is the minimum tensegrity structure octahedron. The 3 compression struts do not touch each other as they pass the center of the octahedron. They are held together only at their terminals by the comprehensive triangular tension net. It is the simplest form of tensegrity. And then another dig at the cube because it's not stable. So that's the minimum 3-strut tensegrity, which is kind of there's like a positive and a negative duality, because now the 6 has to do with the 3. Like here's the 6 struts and the 6 wires, and then here is like 3 struts with a different number of wires, so it's kind of like another minimal kind of atomic pairing. Two 3-strut tensegrities may be joined together to make the tensegrity octahedron. Two 3-strut tensegrities may be joined together to make the tensegrity icosahedron. This form has 6 members in 3 parallel sets with their ends held together in tension. There are 12 terminals of the 6 struts. The 2 octahedra each with 3 struts of 6 ends combined. When you connect those 12 terminals, you reveal the 12 vertexes of the icosahedron. There are 20 triangles of the icosahedron clearly described by the tension members, connecting the 12 points in the most economical omnitriangular pattern. In the tensegrity icosahedron, there are 6 tensional members which join parallel struts to each other. If these tension members are removed from the icosahedron, only 8 triangles remain from the original 20. These 8 triangles are the 8 transforming triangles of the symmetrical contraction of the vector equilibrium jitterbug. See section 460. Consequently, this incomplete icosahedron demonstrates an expansion-contraction behavior similar to the jitterbug, although pulsating symmetrically outward within more restricted limits. So it's like doing quarter squats, doing quarter jitterbugs. So this is still a vibratory, let's just turn it sideways for fun, structure, but these 2 XYZ looking axes are going to form this kind of double parallel structure, and then from there we get the inscribed triangles. So pretty cool. Now we're continuing with this 2 times 3 strut tensegrity icosahedra. If 2 opposite and parallel struts are pushed or pulled upon, all 6 members will move inwardly or outwardly, causing the icosahedron to contract or expand in a symmetrical fashion. When the structure is fully expanded, it is the regular icosahedron. In its contracted state, it becomes an icosahedron bounded by 8 equilateral triangles and 12 isosceles triangles when the missing 6 tension members are replaced. All 12 vertexes may recede from the common center in perfect symmetry of expansion, or if concentrated load is applied from without, the whole system contracts symmetrically, i.e. all the vertexes move towards their common center at the same rate. This is not the behavior we are used to in any structures of previous experiences. These compression members do not behave like conventional engineering beams. Ordinary beams deflect locally or if fastened terminally in tension to their building, tend to contract the building in axial symmetry. The tensegrity beam does not act independently but acts in concert with the whole building, which contracts only symmetrically when the beam is loaded. The tensegrity system is synergetic, a behavior of the whole unpredicted by the behavior of the parts. Old Stone Age columns and lintels are energetic and only interact locally with whole buildings. The whole tensegrity icosahedron system, when loaded oppositely at 2 diametric points, contracts symmetrically, and because it contracts symmetrically, its parts get symmetrically closer to one another. Therefore, gravity increases as of the second power, and the whole system gets uniformly stronger. This is the way atoms behave. So that's pretty interesting about how these tensional long-range connections, wire of 100 meters has the same tensional capacity as any longer or shorter. It's the compressive elements that have the scaling relationship that's not as good. So here's the orbitals and the different shells, like S, P, D, F. So like the S is like a sphere. Okay, makes sense. So we have a sphere packing geometry, right? We were just talking about how the sphere was the minimum radius of 1. So here's our S orbital. Then P orbitals are in the 3 XYZ dimensions with a positive and a negative. Positive and negative tet. Then there's a 4-fold distinction happening in 5 shells. And then even higher distinctions and packings. And so it's just interesting to think about. Not sure if there's a formal connection there or not. Just how these kinds of patterns, do they represent projections from some synergetic geometries? Maybe a little better. So maybe if we used that kind of quadray system dimensionally, think about what the orbitals mean. Okay, so that's the sort of minimal structures. Minimal tet being the minimal system, 4 vertex, and then the minimal tensegrity structures, and how the tet needs those double edges to be a tensegrity structure. So that's about redundancy, because those were the minimal tensegrity redundant systems. And now let's go to the sort of 2 layer, which is Allspace-Filling Tensegrity arrays. So 784, basic Allspace fillers 10. The tensegrity tetrahedron and the tensegrity octahedron are volumetrically complementary, and together they may fill all space. The tensegrity icosahedron refuses to complement either itself or the tetrahedron or octahedron in filling all space, but it isolates itself in space or goes on to make triply bondedly into larger octahedra, which may then complement tetrahedra to fill all space. Okay, so shape, review. Tetrahedra on the left, minimal system. Then we have the octahedra, which is traced out by the minimal tensegrity system, and it's also a regular polyhedra and a simple one, and has a bunch of other features like getting the XYZ. Then there's the hexahedron, aka the cube, and then there's the dodecahedron with 10 sides of a pentagon. That's kind of a special one. So there's like another sections on that, but that's kind of cool to think about. And then there's icosahedron. So icosahedron's kind of like closed. They don't really, they're like grains of sand. So they can kind of pack and swarm in a cool way, but they're like viral particles. So they have a very closed topology. Then remember how we talked about the icosahedron, octahedron, and tetrahedron being the minimal 3 basic systems. So then it's like icosahedron is like closed off, but then the tet and the oct together, they together fill space. They tessellate in space together, but not alone. Tensegrity icosahedra provide by far the most volume with the least structural effort of the 3 basic structural systems. The tetrahedra has the least volume with the most surface. The octahedron is in the middle, and the icosahedron gives the most with the least. So, tetrahedron uses the most paint, most frosting per cake, and the one that looks more like a sphere uses less and less frosting per cake. In the icosahedron, 5 quanta give 20 units of enclosed volume, which mean 4 units of volume for each energy quantum invested in the enclosing structure. Whereas in the tet, 1 quantum will only enclose 1 unit of volume. The octahedron gives 2 units of volume for each quantum. Therefore, the icosahedron gives the most for the least effort. The 3-island tensegrity octahedron, in its positive and negative phases, is fundamental to all tensegrity structures. So, pretty cool and interesting about what does and doesn't fill space. We know that the cube packs well with itself and leaves that voxelated edge. So if we're going to have an edge, let's do integer accounting on shells expanding. 8 icosahedral tensegrity array. The 3 sets of parallel pairs of struts which form the tensegrity icosahedron may be considered as parallel to the 3 axes of the XYZ coordinate system. The same 3 sets of parallel pairs of the tensegrity icosahedron may be considered also as 2 omni-interaxial sets of tensegrity octahedra. This octahedra-icosahedra parallelism relationship explains why it is possible to collect tensegrity icosahedra in approximately unlimited periodic arrays. A set of 8 icosahedra is shown in the illustration. Note that the rows of parallel struts can be repeated to infinity, and the length of each strut can be infinitely long. The tension nets that form the icosahedron edges stabilize the array of struts. So that's pretty cool, and we see those XYZ 90-degree relationships arising. So just you get XYZ 90-degree coordination in an integer accounting 4D coordinate model system, but you're never going to get from Minecraft to TETs. 784.30. Tensegrity icosahedra surrounding a nuclear icosahedron. 6 icosahedra may be arrayed around a nuclear icosahedron in a true XYZ coordinate model. So you can take the nuclear icosahedra, the kind of minimal closed system that way, and then pack icosahedra around it. And that also gives you an XYZ coordinate model, but it doesn't fill all space. but this is like a crystalline packing still. And then 40, limitless array of tensegrity icosahedron. In addition to single strut tensegrity icosahedral systems, it is possible to organize an only time-limited, omnidirectional extensible, uniformly periodic array of tensegrity icosahedron, in which each compression member of finite length is common to only 2 icosahedron. This system consists of a series of omni-interdirectionally staggered layers of icosahedra. A spatial array of 6 icosahedra is shown both as a tensegrity system and as a collection of transparent icosahedra. The lower diagram indicates the method of staggering, which results in each compression strut being shared by only 2 adjacent icosahedra. So you can make these tensegrity arrays. So that could be like a building or a material. All right, then here's just the closing slide discovered when doing a little research today. So this is from limitlessthink.wordpress.com. The words are theirs. The symbol known as the Sri Yantra is an ancient Hindu symbol comprised of 9 triangles that are interlaced in such a way as to form 43 smaller triangles in a web said to be symbolic of the entire cosmos. The 64 tetrahedra grid is also the foundational seed geometry of the fabric of the vacuum. Everything is connected by the structure of this space, the principle behind cosmic entanglement. When you pass light through a 64 tetrahedron, or 3D Sri Yantra, or alternating Merkaba, or vector equilibrium consisting only of straight lines, it casts the shadow of the flower of life consisting only of curves. Sri Yantra thus represents the vector equilibrium and isotropic vector matrix, which is the geometry of the fabric of vacuum. Whoa, didn't know about that. Then on the bottom left, the vector equilibrium, as its name describes, is the only geometric form wherein all of the vectors are of equal length. This includes both from its center point out to its circumferential vertices and the edges, vectors connecting all those vertices. Having the same form as a cuboctahedron, it was Buckminster Fuller who discovered the significance of the full vector symmetry in 1917 and called it vector equilibrium in 1940. With all vectors being exactly the same length and angular relationship, from an energetic perspective, the VE represents the ultimate imperfect condition wherein the movement of energy comes to a state of absolute equilibrium, and therefore absolute stillness and nothingness. As Fuller states, because of this, it is the zero phase from which all other forms emerge, as well as all dynamic energy events which will be described below. And then this page has some cool visualizations of like nested Sierpinski triangles on the planar, but then nested shapes. Here's another nesting. So those are pretty cool. And then here's the last little bit. So if you watch to the end, this is just the little random note that, synchronicities and whatnot. So several of the Trim Tab Book Club people are really into this Janissa concept. So the spherical VE or Janissa crystal. So the spherical VE, here's what it looks like. We'll put it up here. The spherical VE or Janissa crystal. It is to the symmetric arrangement of these 4 hexagonal planes that we align the 4 phi double spiral field patterns in the basic model of cosmometry. In essence, the points of these hexagons all touch the surface of a sphere, and the phi double spiral boundaries define in the simplest manner the great circle vectors of a spherical VE. This form pictured below is known as the Janissa crystal. So that's pretty interesting. Well, been a little bit more than an hour, so appreciate you listening if you've gotten this far. Hope to hear your comments or, never fear to reach out. So the spirit for today was grounding and anticipation and 312. Hope that we got to some of that. So thanks again for watching. Look forward to engaging with you, collaborating with you, see what you want to do and learn and hear about and talk about with Synergetics. So thanks everybody, and peace.